So let's check out some practice 11.1a. And keep in mind that MyMathLab does generate random numbers for the practice each time you open it up. So we are going to be doing exactly the same problems, but probably with different numbers here. So let's check out this first one. And they're giving us two limits here. And if we look at the first one they're giving us, this limit as x goes to 9 from the left, and then the other one they're giving us is the limit as we go to 9 from the right, and they're telling us what these equal. So they're telling us that this is going to be 3, and this one's going to be 2, and we can see 3 doesn't equal 2, and so these limits also don't equal. And if the left and right don't equal, then we say that the two-sided limit, so remember the two-sided limit, there is no superscript, then a two-sided limit doesn't exist. And that's what we would have then for our first answer here. So if we check out the next one, it's doing the same thing. So they're giving us two limits again. And if we look at this one, so we got another left-sided limit and a right-sided limit. And they're telling us these are both 6. So that equals, since the left and the right side equal, means we can then write the two-sided limit, which means x going to 4 with no superscript there, and that equals 6. The two-sided limit will always equal what the left and right equal. And so we got for our choices here, and we have D. It is 6. So number 3, I'm going to switch out for this quick. All right, so for this third one, we've got a linear function here, and it's got a hole in it, meaning that the linear function exists everywhere except where this hole is. And I just wanted to throw out here really quick, how can something like that happen? Is this just some weird type of thing? And actually, this will always happen if you'll always have a hole if you have a function that's in this form multiplied by whatever you got here. So if you have this in your function, you will always get a hole. Now, what you commonly do is you say, well, x minus c divided by x minus c is 1. And so you just get rid of that, and you're just left with the function. However, if you don't get rid of that, you're left with a hole in the function. So, for instance, if I say this, and let me just say this function is x. Well, if we graph this function, this is a linear function, and it has a hole at 2. Now, if you did try to graph this function, you're not going to see a hole because very few graphing programs out there will actually draw the hole. It'll just draw a straight line right through the hole. So these hole functions are something that's real, but you can't see the hole like that so easily. Another point I want to make here is that the limit, because we're talking about limits, the limit always exists at holes, and we'll get into a little bit more about where the limit does and does not exist, but the limit does always exist at a hole. So they're asking us here, this first question here, what is the limit of this function as we approach minus 3? Notice minus 3 has no superscript, so this is a two-sided limit. So we're going to approach minus 3 from the left and the right. And remember back in the video, so how did we approach? Well, we started, say, off to the left somewhere, and we drew a line over to what the output of the function was, and then we started from the right somewhere, and we drew a line out to where the function is, and then as we went closer and closer to -3, so as we go closer and closer to -3, we want to look at if these outputs are converging. And if these outputs are converging, then we know there's going to be a limit. And so that limit will be, whoop, that one didn't work out too well, but limit will be squishing in right onto the hole. So in other words, if these outputs will converge, which they do, then the limit will exist, and the limit will be that point of convergence. So it's converging right at -3, which will give us an output here of 5. So right here. And the next question they have here is for when it goes to -1. And -1 is going to be the same deal. So a linear function, the limit exists everywhere on linear functions. The limit actually exists everywhere on all polynomial functions. So the limit works just like function notation does when you have a function. In other words, putting in -1 will get you the same thing as doing the limit approach, where you have the infinite process. So if we just look at where -1 is, it's going to be right here where -1 is. And if we plug in -1 into our function, if we do the limit around this point, we'll find out that our output is 1. So number 4, let's check this one out. I want to zoom in on that graph. So let's check out this first part. We have the limit as x approaches -2. There's no superscript, so this is a two-sided limit. And -2, so go into the graph here on the left. -2 is right where this first hole is here. And another thing I like to say that's kind of goofy, but it does help with the limit, is so our point of interest is -2. Now imagine that you have little people that could walk on the function. And these people are going to walk on a lot. They're both going to walk towards -2, but they have to walk along the function. And if they can walk towards each other, so if they can keep walking, and if they meet at the same spot, then the limit exists. So if they would walk towards each other, they'd meet right here, and where they'd meet would be the output right here, which is the limit of the function. So we would say here then, the limit for -2 and is going to be 1. So let's check out this next one. As x goes to 0, so 0 here right on the axis. Now again, try to imagine two little people just walking along the function. Now remember, they're walking towards 0. Now the question is, as they walk towards each other, will they meet? Well, as they get closer and closer, remember mathematically we can get forever closer. As they get closer and closer, we can see that they are not going to meet. The person on the left is sitting in an output of 4, while the person on the right is sitting at an output of 2. So these left and right limits don't equal, and so there's no two-sided limit. So there's no two-sided limit at x equals 0. And so for part B, we'll choose option B. The limit does not exist. And let me get a nice zoomed in picture of that graph. All right, so let's check out the first part A here. And it wants to know the limit of this function as we approach 2 from the left. So we do have a minus sign superscript. So we're going to approach 2 from the left. So we're going to approach 2 from the left here. And we're going to do that, of course, along the function. And so again, imagine, little person just cruising along the function. They're walking towards 2. They're going to walk forever towards 2 from the left. And as they get forever and ever closer to 2, what height are they approaching? And so we just look over here and we see they're going to be approaching a height of 1. And that's our left-sided limit there. Now the next question here is, well, what is approaching 2 from the right? So now we have the positive sign superscript. So we're going to approach this from the right. So again, imagine you're a little person. You're walking along the function. You're walking towards 2. And as you start getting forever and ever closer to 2, you want to observe what height are you approaching then? And in this case, you're approaching -1. So what do we got next here? So the next question is, what is the limit as we approach 2? Now notice there's no superscript, so that means this is a two-sided limit. And for the two-sided limit to equal means the left and the right have to equal. But if you look here, the left person's limit is +1, but the right-sided limit here is -1, so these limits do not equal. Since they don't equal, there's no two-sided limit. The two-sided limit does not exist. And then finally, and let me just clear this stuff out of the way here. Oh, whoops. Then finally, they just want to know what the function is at 2. So when we plug 2 into this function, well, what do we get? So this is a little bit weird. And the reason this is a little bit weird is because we have 2 open circles. So we have an open circle here and an open circle here. Remember, the open circle means the function is not defined there. Now, the reason that's a little weird is because usually one of these circles is filled in. Usually one of them is filled in. If that was the case, then f of 2 would be 1. However, that's not the case. There is no function output at 2. There's no function output at 2. It's simply undefined. And so for f of 2, in this case, because we have 2 open circles there, that answer is undefined. Let's check out the next one. I have not completed something. Oh, I guess there's another part. All right. Select the correct choice. So now we have the limit as, oh, I see. We got to do 4 questions for A and B. All right, I got you. I got you, MyMathLab. So 4 minus, approaching 4 from the left. So here's 4. We approach 4 from the left. What height will we be at? Well, we'll be at a height of 0. So the next one we got, if we approach 4 from the right, so if we approach 4 from the right, again, we're going to get to a height of 0. And then finally, what is the limit as x goes to 4? Now there's no superscript, so this is a two-sided limit. And of course, with my little picture here, you can see these people are going to meet as they get forever closer to 4 there. And so this limit does exist, and that two-sided limit will always equal what the left and the right equal. And then finally, we have a function. The last question here, it looks like. Function question, what is f of 4? So if you plug in 4, what's the output? Well, in this case, if you plug in 4, you're going to get an output of 0. And why would they ask that? Well, the reason they'd ask this is because the function output doesn't always equal the limit output. Sometimes they equal, sometimes they don't. Let's check out the next one. And do I need a zoomed in picture of this? Probably not for this one. So we just want to know what is the limit here. So here's our function, this blue line here. And we are going to infinity, so x goes to infinity. So that means as we go forever to the right, and if we go forever to the right, you can see the blue line, the function itself is getting closer and closer and closer to this dotted line. It's getting forever closer to this dotted line. And they're making this dotted line to be 2.75. And so that is the limit. So as this function, as x gets forever larger, this function is getting forever closer to 2.75. All right, so for figure A, you can zoom in here. Our point of interest is 2, so right where the hole is. A limit always exists at holes. And that's what they're saying. They're saying figure A, the limit exists. But in figure B, the limit does not exist at -2. So at -2, if you do the left limit, you can see we're going to end up at a height of -1. But if we approach from the right, we end up at a height of -0.5. So the left and right limit don't equal, which is why this one fails. However, try again, if you can imagine people walking together, they will meet right at the hole. So this limit exists because the left and right equal, and the other one fails because of the left and right don't equal. And so that's what you're looking for here. So this first statement here is the left, so 2 to the minus is approaching from the left, 2 to the plus is approaching from the right. These equal in figure A, and that's why the limit exists. But in figure B at -2, so notice our notation here, x goes to -2 from the left and -2 from the right. These do not equal, and so the two-sided limit does not exist. And that's what they're going for in that one. So we just got a data table here. And looking at the data table, So we can see 7.9999999. We're stacking on a bunch of 9s, so we're getting closer to 8 from the left. And here we're 8.1010001, so we're stacking a bunch of zeros in there, getting closer to 8. And if we look at the output here, we can see the output is approaching 11. So we would say the limit here then is 11. And this one I do need a zoomed in picture of. All right, so unfortunately my MATLAB doesn't have a zoom in there, so I just kind of had to force a zoom there. It looks a little blurry, but you can still see that. So let's check out the first part here. And the name of this weird looking function is t. And so they want us to figure out what is the limit as x approaches 52. Notice there's no superscript, so this is a two-sided limit. And let's look where for 52 is. So 52 is going to be right here, obviously between 49 and 67. So it's right on this line here. And it's going to be about somewhere in here. Either way, when you were on a line, the limit will always exist on a line. So we have a straight line here. The limit will always exist on a line. And this line is at a height of 3. And that's the limit. Let's check out part B. So now we're going to go to 74 from the left. So 74, so here's year 74. You can see there's a break at 74. So we don't have a continuous line anymore. There's a break. And we're going to approach 74 from the left. So that means right here, we're approaching 74 from the left. To approach 74 from the left, we have to be on this blue line right here. That's how we're going to approach 74 from the left. And what height is that at? That's at height 5. So as we approach 74 from the left, we'll be at a height of 5. That is the limit. And so we got for the next one, so 74 from the right now. So to approach 74 from the right means we're going to need to be on this line now to approach from the right. So that means going this way, and we'll look at what height we are at, and we see what height we're at height 6 then. So the limit for 74 approaching from the right is 6. And they want to then know what is the two-sided limit at 74. Now we just figured out that the left is 5, the right is 6. They don't equal. If they don't equal, then there is no two-sided limit. And then finally, they're going to ask us a function question here. What is t of 74? So if we plug in 74, we're going to come up to right here. Now an open circle means there's no function value there. So there's no function value at this open circle here. And so we'll go past that, and then we get to this closed circle. The closed circle is where the function value is at, and that's at 6. And there is practice 11.1a.